Welcome to Module 2, Benefit Cost Analysis in Fisheries. The module covers 6 topic areas through a series of short video presentations, a tutorial and hands-on exercises. Self-assessment checkpoints help you test your understanding throughout the module, and answers to these questions can be found at the end of the module. By the end of this module, you will be able to understand some of the key concepts and techniques that underpin benefit cost analysis, or BCA, scope a project and assess if a BCA is warranted, perform a simple BCA using a systematic spreadsheet approach, distinguish between BCA and economic impact analysis, and know when using each as appropriate. So what is BCA? It is a systematic framework for economic appraisal for proposed projects from the point of view of the public interest. BCA is equally applicable to public and private sector projects. BCA can be particularly useful when projects involve multiple heterogeneous costs and benefits spread across time, space, and stakeholder groups, as is often the case with projects involving natural resources. While the general idea of comparing benefits and costs, pluses and minuses, to see if a proposed project is a good thing or not is uncontentious, BCA is not value-free. BCA applies rational choice theory, and its methods are deeply rooted in the neoclassical welfare economics paradigm. Specifically, BCA is a formal test of whether a project is efficient, in the sense that the amount by which those who gain from the project is large enough to compensate those who lose for their losses, and for the gainers to still be better off. In technical terms, does the project pass the Caldor-Hicks criteria? Note that BCA is not without its critics, and many of the criticisms can be traced to the strong neoclassical economics assumptions and values embedded in its methods. That said, fisheries managers are increasingly required to consider BCA in their day-to-day work, and understanding the basics of the method is invaluable. In addition to informing decision makers on whether a project passes the efficiency test, what are key project variables and sensitivities, and where the important gaps in knowledge or data are, the BCA analyst can highlight the distributional effects of a project on the welfare of different groups in society. Importantly, the BCA analyst can also inform trade-off analysis by identifying the opportunity cost in terms of foregone efficiency when decisions are made on the basis of other criteria. I've been using the term project. That is, any proposal that involves a change in the allocation of productive resources, be it capital, labour, skills, materials, or fish, relative to what will occur in the absence of the project. All of the proposals listed here are likely to comprise a project for the purpose of BCA. In BCA, we refer to whatever will happen in the absence of the project as the base case. The base case could be whatever use of the resources is expected to evolve in the future, which may or may not be the same as the current situation or status quo, or it could be a specific alternative project to the one being considered. Establishing the base case is a crucial step in BCA, as it lets us do the with and without sort of thinking required to identify project costs and benefits. It is only by knowing what the scarce project resources would otherwise have been used for that we can establish a measure of project opportunity cost, which is in turn set against the value of project outputs to determine whether the project net benefits, that is benefit minus costs, is positive, in which case investment in the project is efficient in the Caldor-Hicks sense. The BCA analyst would then recommend the project be accepted or approved. Performing a BCA can be expensive, and the decision of whether or not to undertake one should itself be subject to BCA thinking. In essence, a BCA should only be undertaken if the information gained is expected to contribute to a better decision than would have been reached in its absence. This will be the case when a project which is expected to have a positive net benefit is unlikely to proceed in the absence of a BCA. It will also be the case when a project which is expected to have a negative net benefit is likely to go ahead in the absence of a BCA. To determine whether a full BCA should proceed and to identify data requirements or gaps, the analyst should first perform a preliminary, informal, high-level scoping of the project. As an example of this process, consider a proposed project to translocate southern rock lobster from low to high growth areas in Tasmania. Asking first what the expected benefits of the project are, we find that it is to increase catch per unit effort in the inshore fishing grounds and to improve the quality of catch, resulting in higher beach price. Thinking about costs at the same high level, we identify direct costs of capture, relocation and release. We also expect lower catch per unit effort in offshore areas from where rock lobsters are removed. Thinking now about how we might value benefits, we observe that the rock lobster total allowable catch is allocated through an individual transferable quota system, meaning that, at least in theory, the market price of lease quota provides an estimate of the value fishers place on an additional unit of catch. If the annual cost of the translocation program is less than the value of the additional catch, as measured by the lease value of the additional quota units issued as a result of the translocation program, then net benefits will be positive. In this case, our scoping exercise might lead the analyst to recommend a fairly simple approach to project appraisal, in which we first estimate the net addition to total allowable catch as a result of translocation and use the current annual lease quota price to value this addition. Then compare the value of annual benefits with the annual costs of the less costly option, relocation by charter vessels or by commercial operators. If the net annual benefits of translocation estimated in the scoping exercise are large enough, the analyst might recommend the project go ahead without further analysis. However, if net annual benefit based on the high-level scoping is a small positive or small negative value, the analyst's recommendation might be to proceed with a full BCA, with consideration given to the timing of costs and benefits and the appropriateness of market prices, particularly of lease quota, as a valid measure of project benefits and costs. One of the most technically challenging tasks for the BCA analyst is to value the benefits and costs of a project, which in BCA must be enumerated in monetary terms for each time period of a project's life, typically a year. In project scoping, benefits and costs are usually derived using market data. Recall we used the lease price of quota to value increased rock lobster catch. This is because market prices are generally easily available, but also because, under certain conditions, market prices do actually measure the value individuals put on project outputs and the opportunity cost to the economy of outputs foregone due to the project. When market prices actually do this, we say they reflect efficiency or shadow prices of the resources used. As an example, in one of the scoping exercises, you will have seen that we value the extra output of fish supplied to the market at the gross value of product, based on the assumption that the market price of a kilo of fish is the value the consumer places on it, or their willingness to pay for this extra fish. Similarly, we treat the cost of inputs used in a project as an estimate of the value of the goods that would have been produced if the project resources had been used in their best alternative way, that is, in the base case project. The logic for this needs explaining. In economics, we assume that firms will only hire workers, for example, as long as the value of the output produced by an additional worker at least covers the cost of employing that worker, that is, the wage. This means that when a worker is hired on a project, the market wage measures the value of the output foregone in the worker's alternative employment, that is, the project opportunity cost. In the real world, however, things might not be so straightforward. Firstly, projects may have benefits and costs that are not directly revealed by individuals through their participation in markets. For example, some projects have effects on the environment, such as some trawl fishing, and some uses of fish resources, such as non-commercial recreational fishing, are not traded in markets. The solution is to use one of the many non-market valuation techniques developed by economists, or to note these values as emissions to BCA calculations and to qualify results appropriately. It is worth noting that these non-marketed values are common in marine systems, as shown by the wide variety of different types of values which economists recognise as being relevant to economic analysis and the different valuation methods that are put to use. But again, non-market valuation is a project in itself, and the process of project scoping should be used to determine whether it is an efficient use of resources. For example, if project net benefits are negative without considering possible negative environmental effects, non-market valuation will not contribute to better decision-making and should not be undertaken. So we've seen that missing markets are a problem for valuation in BCA. But there is a second potential problem. Even if market prices exist, they might not be valid efficiency or shadow prices. This is common and will occur where markets are not competitive. For example, if there is only one seller of a good, a monopoly, or where there are taxes or regulations, such as a minimum wage, that distort market prices. The solution in this case is to use shadow pricing techniques and rules to adjust observed market prices to make them reflect the true marginal benefit or marginal cost to the economy of changes in outputs of goods and services. Examples of where shadow pricing might be needed is if resources used in a project would otherwise be unemployed, or where imported goods that are subject to tariffs or quotas are used. But, at the risk of labouring the point, the BCA analyst should not invest time and other resources shadow pricing items that play only a minor role in determining the overall project net benefits. The question of which outputs and inputs should be shadow priced should be a consideration at the project scoping stage. Project appraisal of any sort is subject to great uncertainty, and this is particularly true of natural resource projects. Sensitivity analysis is a common response to this uncertainty and should form a part of any BCA. It provides decision makers with important information about project uncertainty and helps focus attention on critical areas of judgment. Sensitivity analysis consists of the following steps. Select a few key but uncertain variables involved in the BCA. By key, we mean those variables that make a real difference to the overall net benefit of the project. Identify a range of plausible values for each key variable and recalculate project net benefits for a number of values in the plausible range. Finally, analyse the sensitivity of project net benefits to the value of each variable and calculate break-even values if needed. Break-even values refer to the value of the variable at which the net benefit of the project becomes negative. The final topic we're going to cover before we get our hands dirty with an actual BCA is the link between economic impact analysis, or EIA, and benefit cost analysis. Sometimes proponents of a project want EIA to be included in a BCA, often in the hope it will reveal additional project benefits that are not already captured in the BCA. BCA and EIA use some of the same data, but beyond that are very different things. In particular, they use different methods, and most importantly, they address quite different questions. Decision makers may consider both EIA and BCA alongside other types of information as part of a multi-objective decision process, but only very occasionally is there a valid case for actually incorporating economic impacts into a benefit-cost analysis. The economic impact of a project is often measured by its effect on the following measures: the value of output, value added, employment, or household income. However, the most complete and reliable measure of economic impact is the change in gross domestic product or gross state product brought about by the project. But recall that project net benefits, as calculated in BCA, is a measure of the value of output of a project net of its opportunity cost, or the loss in value of output from diverting resources from their alternative use, and as such is a rough guide or measure of the change in GDP. I say a rough measure because the project may have effects on things that are not captured in GDP, such as environmental effects, and some costs and benefits may occur outside the country. Note also that even if a project occurs in an area of high labour unemployment and generates output without having to reduce output elsewhere, this benefit is already accounted for in BCA by shadow pricing labour, so that its opportunity cost to the project is less than the market price. To include this benefit as an additional economic impact would be to double count. So what about the indirect economic impacts that might occur due to a project demanding goods and services from other sectors? Again, while this could create additional net project benefits in the form of wages or rents paid to workers or other resources, this will only occur if these would otherwise be unemployed. In the case of fisheries, many of these indirect impacts occur outside the local community or region, and the generation of genuine additional net benefits in this way would require general economy-wide unemployment of the relevant resources. So what of indirect or flow-on effects due to the spending of incomes generated by the project? These flow-on effects are measured by the multiplier, which tells us how much a dollar increase in income will ultimately increase the value of output of goods and services through induced spending and re-spending of income. The question then is whether we expect multiplier effects to be small or large. A multiplier effect will be larger when taxes and social security payments, such as unemployment benefits, are low, when induced spending occurs in the same region as the project, and of course, where spending is on goods and services produced by resources which would otherwise be unemployed. And finally, even in cases where there is a significant multiplier effect beyond that measured by the project's net benefit, this will be relevant to the BCA only to the extent that the project under consideration creates benefits relative to those created in the alternative or base case project. In other words, it is the difference between the multipliers associated with the alternative projects competing for the use of the scarce resources that really matter. We are now going to consolidate the concepts covered in the module by stepping through the stages of two relatively simple benefit-cost analysis using a systematic, transparent framework presented as an Excel spreadsheet. The focus of the first example is on developing the skills needed to enter data and to conduct a simple discounted cash flow analysis that is needed when project costs and benefits occur over time. If you're not familiar with the logic and mechanics of discounting, you should take time now to view Tutorial 1. This BCA is conducted as a market analysis, that is where project benefits and costs are valued using market prices. This will of course be the same as a test of project efficiency, when all project outputs and outputs foregone are bought and sold in markets, and where these market prices represent shadow prices. In the second exercise, our focus is on making sure the analysis is a genuine efficiency BCA. We also use the systematic spreadsheet approach to show how the project affects different stakeholder groups. That is a distributional analysis. To get started, open the Word document, BCA Worksheet, and the Excel file, Exercise 1, Abalone Stock Enhancement BCA. The worksheet includes a summary of the basic Excel commands used in these exercises. Our first task is to read the project information for the Abalone Stock Enhancement project. It is then to extract the project data for the market analysis. This data is then entered in the data field at the top left-hand side of Sheet 1. Note that the first rule for using the spreadsheet is to enter data only once, in the yellow shaded cells. The actual analysis will then use data by referencing the cell containing the original data entry. For example, if you want to use the real rate of interest in any calculations, you would refer to it as B10. In this exercise, the real rate of interest is calculated automatically using the formula introduced in the discounting tutorial. The next step is to construct the annual flows of project costs and benefits. You will need to follow 3 rules to do this. First, label the initial year of the project as year 0, with subsequent years labelled 1, 2, 3, etc. Enter benefits and costs in the column related to the year in which they are incurred. Secondly, enter the values of each of the project inputs and outputs in a separate row. Thirdly, enter benefits as positive values and costs as negative values. In the Abalone Stock Enhancement project, reseeding occurs over a 10-year period, starting a year from now, so that annual costs are entered in years 1 to 10. The initial cost of facility refurbishment occurs now in year 0. Because of the delay in recruitment to larvae to the fishable stock, the extra catch will be entered in years 5 to 14 inclusive. The next step is to calculate the net annual benefits of the project. Note that having entered benefits as positive values and costs as negative values means that net benefits in each year will be calculated by adding benefits and costs. As explained in the tutorial on discounting, the fact that project costs and benefits occur at different points in time means they must be reduced to their present value to determine whether the project passes the Caldor-Hicks efficiency test. Conveniently, Excel lets us calculate the present value of the stream of project net benefits using the NPV function. A useful exercise is to demonstrate that this does in fact give the same result as discounting the streams of benefits and costs separately and subtracting the present value of costs from the present value of benefits. You are now in a position to calculate the NPV of the project. The result is negative $49,991. This tells us that adjusted for timing, the value of the outputs created by the project do not exceed the value of the outputs that would have been lost by having the resources employed in their alternative use. The project does not pass the Caldor-Hicks efficiency test. We've now completed exercise 1.1 to 1.3 together. By changing the value of key variables in the data section and recalculating the net present value, you can perform sensitivity analysis. Pause the video and perform the sensitivity analyses in exercises 1.4 and 1.5. Be sure to record your results in the table in the worksheet. Results of the sensitivity analysis indicate that for the range of values of extra quota investigated, between 40 and 60 tonnes, the project net present value varies between a loss of about $370,000 and a gain of about $270,000. This is clearly a key project variable. The break-even tonnage, that is the value of extra quota at which the NPV of the project turns positive, is calculated as just under 52 tonnes. The sensitivity analysis of the real rate of interest confirms that it is also a key variable in the analysis, with the project NPV being positive for a real rate of interest of only 1% point less than the initially assumed value. It is worth noting that, as expected, higher values of this variable reduce the project NPV. This is consistent with the structure of costs and benefits in the project, with costs generally being incurred early in the project life and benefits occurring in later periods. Since the higher discount rate reduces the weight given to future values relative to those occurring earlier, a higher discount rate makes this project less attractive. This pattern of benefits and costs is common in natural resource and environmental projects, making them seem unattractive when evaluated using high discount rates. The last question in exercise 1 asks you, the BCA analyst, to make a recommendation based on the analysis you have just performed. The NPV of this project has been shown to be highly sensitive to key variables about which there is uncertainty. From a BCA perspective, more information about the efficiency of market prices would be needed before any clear recommendation can be made. It is now time to tackle a slightly more complicated exercise. To get started, open the Word document, BCA Worksheet, and the Excel file Exercise 2, Skills Upgrading in the Fishing Industry. Pause the video, and using the rules for using the systematic spreadsheet approach and your experience in conducting a market analysis in the previous exercise, answer exercises 2.1 and 2.2 using sheet 1 of the spreadsheet. You can check your answer by opening sheet 2 of the spreadsheet. One important thing to note in the market analysis is that we did not include either the fee paid by the trainees or the contribution of the Fishing Industry Development Fund. BCA includes only real resources devoted to the project and the real outputs generated. In the context of this example, the two items mentioned are not real costs. Rather, they are transfers from one group to another. If we include them as a cost to one group, we would then have to enter them as a plus to another, and so they will cancel out. Note, however, you will need to use them later when we consider the distribution of benefits and costs across stakeholder groups. On the basis of the market analysis or scoping stage, your view as the analyst would be that the training program is marginally unfavourable. At this point, you should bring your judgment to bear on whether there are any redeeming features of the project that we have not taken into account. For example, we assumed that the skills learned would become obsolete after only 5 years, but perhaps benefits will continue to flow beyond this period. We also did not take account of the reduction in the trainees' home consumption of food, a benefit to them while they are in the program. While we do not take account of these effects formally, we should bear in mind that they are favourable to the project. Exercise 2.3 asks you to perform an efficiency analysis of the project. Suppose that further investigation on the cost side finds that the course is scheduled for the mid-semester break, when the classroom facilities would otherwise be unused, and their opportunity cost is consequently zero. You also discover that 3 of the trainees would otherwise be unemployed, so their opportunity cost is the value they place on their leisure time. It is common to value the time of the otherwise unemployed at less than the market wage, and in this case we use an estimate of 50% of the wage. Again, pause the video. Conduct the efficiency analysis by replacing market prices with the true opportunity costs of trainees' time and classroom space as just discussed. You can check your result against sheet 3 of the spreadsheet. If the criterion is economic efficiency, the project appears to be marginally worthwhile. However, if any of the groups involved decided not to participate, the project would not proceed. We now conduct a distributional analysis to measure the net benefit to each of the groups involved: trainees, the Maritime College, the Fisheries Department, and the Fishing Industry Development Fund. As well as providing useful information to each group and confirming the viability of the project, the distributional analysis provides a useful check on the accuracy of the analysis. The sum of the net benefits to the individual groups involved should equal the net present value identified by the efficiency analysis. Pause the video again and try exercise 2.4. You will need to create sets of rows representing the benefits and costs and compute the net present value for each group separately. Remember that you can check your results by summing the group's net present values. Confirm the respective net present values as shown and that they sum to $1,076. Check your answer against sheet 4. The distributional analysis indicates that the project proposal has a positive net present value and will be viable if the 3 organisations concerned can accommodate it within their budgets. Your calculations have shown that as a group, trainees benefit by over $57,000, but recall that some of the trainees would otherwise have been employed. We can further refine the distributional analysis to check whether this subgroup have an incentive to enrol. Complete exercise 2.5 to confirm that the net present value to this subgroup is positive. Assume that the proportion qualifying is the same as for the group of trainees as a whole. Check your answer against sheet 5 of the spreadsheet. Let's take a moment to recap the steps taken so far. We have worked through the BCA in a logical manner. First, scoping the project and identifying the inputs and outputs involved. Then, valuing these goods and services at market prices. We then applied our judgment to determine whether there were any omitted factors and whether market prices truly reflect benefit or opportunity cost. The BCA was then revised to give a best estimate of net present value. The calculated net present value was then divided amongst the groups involved and the viability of the project established. The final 2 exercises ask you to complete the BCA by performing a sensitivity analysis for the project and by writing a brief report on the BCA of the skills upgrading project proposal under the following headings: project description, including a list of outputs and inputs; market analysis, including a description and justification of the prices used to value output and cost inputs; efficiency analysis, detailing and justifying the departures from market prices; and finally, distributional analysis, describing who benefits from the project and who pays and by how much. Your report should conclude with a recommendation based on whether the project constitutes an efficient and viable use of scarce resources.